Square Tech Lab channel. We are still on the same topic of dynamic routing protocol. On our previous video, we've been actually focusing or basically trying to configure the OSPF routing protocol. But on today's topic, we'll be focusing on the routing information protocol. This is another dynamic routing protocol, which is a distance vector. It uses the metric of hop counts. So the lowest hop count, that part will be preferred by the routing information protocol. Okay, the administrative distance of this routing information protocol is actually 120. Okay, if you compare the OSPF with the routing information protocol, the OSPF will be preferred because it have the lower administrative distance, and it's also capable for larger network infrastructure, and also it have the lowest administrative distance of 110. That is the OSPF, but this one have 120. Okay, and the reason why this can never be preferred over the OSPF is because this one is not scalable toward that extent. How? Because if we can have more than 15 hops on that network infrastructure, the routing information protocol won't be able to support more than 15 hops. Okay, which is why this is also good for only small businesses. So let's dive in and see exactly what do we have on this lab setup. We have multiple local area networks. Okay, I can just say we have different VLAN IDs. We have VLAN 10, we have VLAN 20, we have VLAN 30, we have VLAN 40, we have VLAN 50, we have VLAN 60. These are different broadcasting domains that we have on our network lab, and all of these VLAN, they are utilizing the subnet mask of 255.255.255.224. Why is that so? Because we actually using /27, which only allows 30 usable IP address on each broadcasting domain. Okay, so we also trying to use multiple routers so that we will actually demonstrate how the packet move across from different VLAN towards another VLAN, utilizing that lower number of hop. Okay, lower number of hops count on its path. All right, so we're just gonna dive in and actually do all of those configuration. But first, we will start with configuring the VLAN IDs on these layer 2 switches. We will associate these interfaces with those VLAN 10 that on this, specifically on that switch, and then here we will be utilizing all of those interfaces to be associated with VLAN 20. Same thing applies to all of these broadcasting domains. All right, remember all of the interfaces on the switch, they are collision domains. All right, so what we're gonna do about this interface, we're gonna try to encapsulate .1QTech on this, and then we're gonna try to use this as the sub interface on FA0/0 on this router over here. Same thing applies on this router, same thing applies on that router, same thing applies on that router, same thing applies on that router. The list goes on and on and on. We're just gonna utilize the sub interface to configure the VLANs. All right, this is called on-stick routing. So what do we have also here? We have these /30 IP addresses that we have actually used. We have actually used different number or different IP addresses so that when we try to run the trace route, we'll be able to see exactly which hops are gonna be listed on those trace routes that will be running on all of those end host devices. All right, so we have 10.10.10.0/30 between R6 and R1, and then we actually have 20.20.20.0 between R1 and R8. All right, the list goes on and on and on. Remember, /30 only allow 2 usable IP addresses. We can't actually use more than that on /30. Right, so where do we start now? Well, let's start from here. What do we do here? We're actually trying to associate all of those interface with that VLAN 10. The first thing we do is to create the VLAN 10 and give it a name VLAN 10. Right, and then we exit, and then we have to type the command FA0 In this case, I would start from 2 because this interface is going to be used as our trunk interface. Remember, we can't actually give this interface the IP address because this is a layer 2 switch. It doesn't actually understand the IP addresses. So basically, I cannot be able to run the command no switch port and assign this IP address on that interface specifically. So I'm just going to start from this range FA02 up to 24 and type in the command switch port mode access. Okay, and then switch port access VLAN 10 that we just created. I'll type in do right, and then I will say interface FA0/1 switch port mode trunk. I'm trying to make this interface as a trunk link. Do right. Okay, no shut down. All right, so now that interface is actually up. Let's go back to this switch over here. I'm just going to minimize this, or let's go back to this switch. We're going to try to run the same command on this switch. We have to enable this switch by tapping the command config terminal, and then we can actually configure the host name by tapping the command host name and give it maybe switch 2. This is just for demonstrational purposes. You can give it any name that makes sense to that network topology. So in this case, I'm just going to use this as switch 2. So after that, let's just try to create the VLAN by typing the command VLAN 20, give it a name. In this case, I'm just going to say VLAN 20. This is just the name. This is an alias, and then let's associate all of those interfaces with that VLAN 20 by selecting the range of those interfaces and exclude this one. So we're going to start from range 2 up to 24 because there are 24 ports on that specifically on that device. So let's just run the command switch port mode access switch port access VLAN 20 and then interface, let me just say no shut, even though those interfaces they are up. So now let me select fastnet 0/1 and then I'll just say switch port mode trunk. Okay, do right, no shut down. That interface is actually up now, which this is the interface. Now let's go back to this route, this switch over here, which is the layer 2 switch. Enable config terminal. This host name switch 3. Let's create the VLAN here, which is VLAN 30. A name VLAN 30. Exit. Interface range from FA02 up to 24 switch port mode access. Let's say switch port access VLAN. This is VLAN 30. Exit. Do right. Interface FA01, which is let me show you, which is this one. Actually, this is FA06. So which means now we have to go back and exclude this interface because we have included it on that range. It falls under this range, so we need to go back there and exclude it. So let's just select this interface and associate it with that VLAN. Access VLAN 30. Exit. Interface FA 0/6. No switch port. Access VLAN 30. Interface FA 0/6. Switch port mode trunk. Do right. Okay. Now let's say no shut. This interface will only go up once that interface on those routers they also configured with no shutdown configuration. So Let's move to this VLAN over here, which is VLAN 40. We're going to try to do the same thing also. Enable config terminal. Config terminal. Let's give it a name, which is a host name of switch number 4. Okay, let's create a VLAN here, which is VLAN 40. Let's give it a name of VLAN 40. Exit. Let's select the range of all of those interfaces associated with that switch, which is start from FA0/2 up to 24. We need to say the range, specify the range in here, and let's say switch ports mode access. Now let's say switch port access VLAN. Which VLAN is this? This is 40. Exit. Now let's select the other interface that we're trying to make it as trunk. Switch port mode trunk. Okay, do right. Okay, now let's move on to this switch over here and run the same configuration. Host name. This is switch 5. I'm trying to create the VLAN 50, and I'm just gonna give this name VLAN 50 and exit interface range from FA02 up to 24. And I'm actually trying to associate these VLANs, this interface with VLAN VLAN 50. Do right. So let's select the other interface, which is actually interface 501. Switch port mode trunk. Do right. Okay. Now let's go to let's say no shutdown. Okay, do right. Let's go to this last switch here. Enable config terminal. Switch host name. This is switch 6. Create the VLAN, which is VLAN 60. Give it a name, VLAN 60. Exit. Let's select the range of all of those interfaces that we're willing to associate with the VLAN that we created. We're starting from 2. Range FA02 up to 24. Switch ports mode access. Switch ports access VLAN 60 that we just created. Exit. Let's select the interface to associate with the trunk. So this is the interface, which is F1. Switch port mode trunk. Do right. No shutdown. Do right. Okay, we have actually tried to configure all of those interfaces to associate them with these VLANs that we have created on each VLAN ID on these switches. Right. Let me just try to go back to that interface. Okay, it's actually up. So let's go to this one and double check. No shuts. Down to right. Okay. Now I need to actually go to these routers and assign the IP addresses on all of them. To assign the IP address, I'm just gonna demonstrate with only few, and then I'm just gonna pause the video and continue once I'm done with assigning all of these IP addresses on all of these respective interfaces, because it's actually going to take long to assign the IP addresses on all of those interfaces. I'm just going to show maybe with 3 routers and then pause the video and continue with other routers. All right, now let's start with this router over here. What do we know about this router? It have only 4 interfaces, and we actually know that we need to configure, this is a layer 3 device, we need to actually configure the IP addresses in order for those interfaces to be functional. Right, now let's do this. Enable config terminal. The host name is just gonna be R8. Sorry, basically it's R6. Okay, so let's start with that interface, which is serial 3 SE interface SE3 /0 IP add 10.10.10.1. The subnet mask is 255.255.255.252 because this is /30 that only allow 2 usable IP addresses. So no shut, do write. I'm not gonna configure the clock rate on all of these serial interfaces. I'm just gonna leave it as it is. No shutdown, do write. So let's move on to this interface. Which is SE6 /0 interface SE6 /0 IP add. This is 80.80.80.80.1 255.255.255.252 and no shutdown. Maybe I can just say, okay, I'm not gonna configure the description link. Let me just leave it for now. So let's try to configure that interface as well. Interface SE 2 /0 IP add 70.70.70.1 255.255.255.252 no shutdown, do right. Okay, let me do this, do right. Okay, now let's configure the last interface on this router. Remember, on this time around we need to configure something called the sub interface. Right, we're trying to configure the sub interface for this local area network. So this is going to be the default gateway. First thing I want to do is I want to select the interface, which is interface FA0 /0. Let me just say interface FA0 /0.10. Okay, 0.10 because I want to access that VLAN 10 on that sub interface of this interface 5900. So I will type the command encapsulate .1q .1q. Okay, and then this specify the VLAN ID of that interface. So basically, let's just assign the IP address now. IP add 192.168.10.1. This is gonna be our default gateway 255.255.224. Remember, this is /27, so we're gonna use 224 in this case. And then I'm just gonna say no shutdown. Remember, the interface won't go up because I'm running the command no shutdown on the sub interface of that interface. So I actually need to select that interface, which is interface FA0 /0, and run the command no shutdown from that interface. As you can see now, the interface just went up because I have actually told that interface to say I want to hook you up. Okay, do right. Now we're just gonna do the same thing on all of those routers. Let me move to this router over here. Enable config terminal. This is the host name of R1. What do I know? I know that there are 2 directly connected interfaces here, which is this interface SE2 /2 and SE3 /0. Sorry, SE2/0 and SE3/0. So I'll select one of the two. I can start with any interface SE2/0 IP address, which is 10.10.10.2. This is the last usable IP address on that network ID, which is 10.10.10.0/30. The subnet mask is 255.255.255.252. Okay. No shutdown. As you can see, after I've typed the command no shutdown, the interface is just gonna go up. Now I can be able to do a ping to 10.10.1. So I can do a ping 10.10.10.1. As you can see, we have the successful rate. We have sent those ICMP echo reply, and then we get echo or request, and then we get the reply. Okay, now let's move on to the other interface, which is interface serial 3/0. We're willing to associate that interface with the IP address of 20.20.20.1, 255.255.255.252. No shutdown, do right. Okay, that is the IP address that we have actually given to that serial 3/0. We have used first usable IP address on this network ID on that serial E3 serial 3/0. Okay, so let's now move to the dead router, which is this one. This is where I'm actually gonna pause the video so that it won't take longer. So I'm just gonna pause the video and associate all of those interfaces with the respectively IP address that we're willing to give in here, and then I'll just come back for it with the routing information protocol. So let's select that interface, which is interface SE2/0, and then we're willing to add the IP address of 20.20.20.2 with the subnet mask of 255.255.255.252. No shutdown. As you can see now, if I can try to do a ping to 20.20.20.2.1, sorry, I can be able to actually, let's wait for it. I can be able to see that there is a successful rate of 80%. If I run it again, I would get 100. As you can see, we are now getting the 100%. We have sent the echo request, and then we're getting the reply of ICMP. So now let's try to see if we can ping 10.10.10.1. Do ping 10.10.10.1. Of course, I won't be able to ping it. The packet will be dropped because on the routing table of the router, or on the router that I'm actually running the command from, there is no entry toward that destination, right? Which is why we need the dynamic routing protocol. In this case, we'll be using the routing information protocol. Let's move on to the other interface, which is serial interface serial 3/0. IP at 30.30.30.1, 255.255.255.252. No shut down, do right. Okay, so I'm just gonna pause this video from here, and then I'll continue to all of these routers, and then I'll give the IP addresses. As you can see, I have to go here and utilize this network ID. I will have to go through this point-to-point communication between these two routers, and then associate these IP addresses with all of these interfaces. Okay, once I'm done with the configuration of all of these interfaces, I'll just come back with the video continuation of how to configure the routing information protocol. Okay, so basically we have done doing the configuration of all of these IP addresses that you see between the routers. From this router here, we've been doing the configuration that we've been doing on all of these routers here before we pause the video. So basically it's all the same configuration. It's just that each interface have the IP address that belongs to that network ID. Okay, and we have used the common way of configuring the sub interfaces on this interface. For instance, if I click on this Y, as you can see, we have actually configure this sub interface by typing the command interface fastnet 0/0.50, which belongs to that VLAN ID. Okay, and then we have typed this command encapsulation.1q tag because this is a trunk link, and then we have specified the VLAN ID, and then we have actually added the IP address of that as our default gateway of that VLAN ID, and then we have used the subnet mask as our network ID that belongs to /27. Right, so this is the command configuration that we've done on this interface, on that interface, and also on that interface, as we did on this interface when we starting to configure this router over here. So we have actually assigned the IP addresses on all of these interfaces here. I'm just gonna demonstrate by typing the command enable show IP interface brief. This is gonna actually show me that we have IP address that we have assigned on that, specifically that the router over there, which is 10.10.10.2. that is the interface, which is serial 2/0, and then also we have that serial 3, which is 20.20.20.1. as you can see, same thing applies on all of these routers. If we run the same command, we will be able to come up with the same result but with different IP addresses corresponding to the interfaces, okay, that are belonging on those routers, and also depending on the network ID that is used between those two routing devices. So now let's try to configure the DHCP. We're just gonna configure the DHCP just before we go to the routing information protocol. Let's configure the DHCP on all of these routers that have the local area network attached to them, so that we won't have the need to go through each and every device and try to get them to have those static IP addresses manual. Okay, so basically let's start by this one and create some sort of a DHCP server on the router, so that it will dish out or create a pool of IP address that can be linked to this network ID, okay, of 192.168.10.0. We have used the first usable IP address as the default gateway of that VLAN, and also same thing applies on all of these network IDs. So in this case, we have used .1, we have used .33, we have used .65, we have used .97, we have used .129, we have used .161 as the default gateway that correspond to the VLAN IDs. Right, so now we have to type the command ipdhcp. Let me just do this in lower cases. ipdhcp pool. I'm just gonna say I want to pull actually VLAN 10. All right, okay, this is just an alias name, and then I need to actually specify the network that I want to pull. This is the network of 192.168.10.0. all right, and I need to specify the subnet mask that is used on the network ID. It's actually this one over here, 224. all right, now I need to specify default router, which is the default gateway that I've utilized again when I was configuring that sub interface. So I actually need to configure that IP address assigned on the sub interface of the trunk link. So basically I'm just gonna use 192.168.10.1, and then I need to specify the DNS server. In this case, I'm just gonna utilize 8.8.8, and then I will just say do right. I'm not gonna set up the DHCP excluded IP addresses in this case. I'm just gonna leave everything as they are. Okay, so let me just say exit do right. Right, let me go to this router as well and do the same thing. On this router we have actually let's run the command IP DHCP pool. We have VLAN 30, so I'm just gonna say VLAN 30, and then I will just specify the network. In this case, the network ID that is utilized is 192.168.10.32. That is the network ID of that VLAN. So the subnet mask is still the same, 255.255.255.224. Right, and then default router, which is the default gateway that we have utilized, is the first usable IP address on that network ID, which is 192.168.10.33. Okay, and then the DNS that we will be using is 8.8.8.8, and then we don't need to exclude some IP addresses for now. Let's just leave everything as there. So now let's move on to the router over here. Remember, this is not the routing. We're just trying to allow this IP address to obtain the IP addresses, at least from the DHCP server here. We don't need to manually configure the IP address on those devices here. So let's do that before we go to the routing protocol. So I need to exit from this interface and type the command IP DHCP pool, DHCP pool, and then I need to specify that I'm trying to pull VLAN 30 for now. So this is gonna be VLAN 30. I'm just gonna say VLAN 30, and then on this VLAN 30 I want to say the network ID that I want is actually gonna be 192.168.10.64. This is the network ID of this domain. So, and then the subnet mask that will be utilized here is 255.255.255.224. And then the default router, which is the default gateway that we used on the sub interface that was configured on this trunk link over here, is just gonna be 192.168.10.65. Okay, and then the DNS server is gonna be 8.8.8.8 for now. Exit. Let's create another pool on the same router, which is IPDHCP pool. We're trying to pull VLAN 40 this time around. VLAN 40, this is just the name, remember, it could be any name. So the network ID is actually 192.168.10.96. that is the network ID. So the subnet mask is 255.255.255.224. Okay, the default router here, which is the default gateway, is 192.168.10. And then remember, we're using the sub interfaces IP address that we have configured in here, which is 97, and then the DNS is gonna be 8.8.8.8. Exit. Now let's move on to these last two routers. If we come here, we just gonna enable the router. Okay, let's give it the host name again. This is R3, and IPDHCP pool is gonna be, let's say, VLAN 50. This is the network is actually 192.168. This is the network ID .10.128. Right, the subnet mask of this network ID is actually 255.255.255.224, and then default router is going to be 192.168.10.129. Okay, this is the default gateway or the IP address that we have actually configured on that sub interface of this interface, which is a trunk link. It encapsulate.1q tag. Okay, now let's configure the DNS server, which is 8.8.8.8. Okay, exit. Let's move on to that interface as well, which is located on this router over here. Enable config terminal. IPDHCP pool, DHCP pool, VLAN 60, network 192.168.10.160. Okay, and let's just specify the subnet mask of 255.255.224, and then the default router here is just gonna be the IP address of the sub interfaces. Again, the sub interface that was configured on this interface, fastnet 0/0 dot 60. So it's just gonna be 10.161. That is the first usable IP address on that network ID. So in this case, let's just do this 255.255.255. No, we don't need to specify this. Remember, we've done this already on the network ID. So I can just configure the DNS server and put 8.8.8.8. Do right. Okay. Now, if I can try to go to these devices, they should be able to obtain the DHCP server from those routers. Okay, as you can see, those devices, they can now be able to get those DHCP pool that are leased. So basically here we are expecting to get the IP addresses that fall to that falls below 30, that falls below 30, 10.30, so up to 29 and up to 30 as well. We don't expect to see the broadcasting IP address assigned on any of the devices, which is 31. 31 is the broadcasting IP address of that network ID, 192.168.10.0. Okay. So again, if we come here, we're expecting to see that the leased IP address starts from 31 upward. From 34 upward, because 33 is utilized as our default gateway. Okay, so let's see if we're gonna get that 34 or 35. So on our first request, this is Dora, we discover. Okay, so basically, as you can see, we got 34. If we move along, we will get 35. Okay, so basically the broadcasting IP address on this network ID is actually 63. So we don't expect this to have 63 IP address assigned on any of these devices over here. So if we come here, we're expecting to see that the first usable IP address on this network is actually going to be 66, because 65 is utilized as our default gateway, which is configured on this sub interface over here. So if I click on this one, I'll be able to see that the first usable IP address is .66. As you can see, this is the IP address that is used. Again, the broadcasting IP address of this network ID, which is 64, the broadcasting IP address is going to be 90. It's going to be 95. All right, so we don't expect any IP address, any device on this domain to be assigned with 192.168.10.95, because that's the broadcasting IP address of this network ID, which is 192.168.10.64. Now let's move on to that IP address that we need to see on this domain. So as you can see, we have 192.168.10.96, and we have used 97 as our default gateway. So we're expecting to see the lease to start from 98. Okay, so let's do that now and see if we're gonna get that lease starting from 98. As you can see, we actually have 98 here. Let's do this. Okay, this is .99. Now let's move on to this this VLAN 50 and do the same thing. We are expecting to request okay, as you can see, we have actually got 130, because the default gateway here was used as 129 on the sub interface, As you can see, this is the default gateway, which is 129, and then the first usable IP address is going to be 130. The broadcasting IP address of this network ID is going to be 159. Okay, so we don't expect any device in here to utilize 159. Okay, because that will be the broadcasting IP address of this network ID of 192.168.10.128. Now let's move on to the last one, which is VLAN 60. I'm just going to do the same thing. As you can see, we're expecting to get 162. So this is the first usable IP address of the network ID of 192.168.10.160, and this is the default gateway that we have utilized on the sub interface in there. That is the interface that we will use to break out through the network. So in order for this device to be able to communicate to each other, they will need to utilize something called the routing information protocol, or the dynamic routing protocol. So in this case, we're going to be demonstrating using the routing information protocol, the RIP. Okay, remember, now it's time to do that configuration of RIP. So all we have to do, again, we need to select the router and create that instance, as we've been doing all along with OSPF, where we actually specify the router ID, so the router process ID. So in this case, we were just saying router router OSPF, and then we specify that ID. So in this case, let's start by this one over here. Or maybe before we just do that, let me show you exactly that currently we cannot be able to ping any device on the network. I'm just going to try to, I'm just going to try to simulate this so that you will see that the packet will be dropped on this router here. You will see the cross on this router here, which means this router have no idea of how to get to this VLAN 20. Okay, so let's do that right now. Let's try, this router over here will have no idea to get to VLAN 20. Okay, let's do this right now. I'm just gonna simulate this. What are we expecting to see here? We're expecting to see the packet being sent to this router here, and then the switch will just flood the packet to each and every interfaces except from the interface that it received the packet from, because this is called the app. So basically, this is what's going to happen on the first time when you're trying to discover the MAC addresses. So basically, this switch will flood the packet to everyone except from the device that received the packet from. Once the packet is being flooded, and then it will move across, but let's do that now and see what's going to happen. We're trying to send from here to here. I'm just going to play this so that you will see that the packet will be dropped. This is the app. Okay, let's see. Packet was sent to the switch, now it's going to be distributed with the broadcast to each and every one. Okay, as you can see, it was as you can see, this interface, because it came from this interface, this one didn't receive it. Now let's see what's going to happen. Let's see now what's going to happen and see if these devices will be able to communicate one another. This device and that device over there. As you can see, the packet was just dropped over there. If I can try to speed up this, you can see that let me try to do this. I'm just going to try to ping that device over there, because I know the IP address is 34. I'll do a ping 192.168.10.34. As you can see, the destination is actually unreachable. We need to come to this router and actually try to verify if there is any routing protocol that is running on this device by typing the command do show IP route. Okay, as you can see, we only have those directly connected interfaces. There is no RIP land in here. We don't have any R that we see in here that shows that there is a entry on this routing table for the RIP. Okay, first and first, before we configure the routing information protocol, we just need to type the command router rip. Okay, and then we need to specify the version, which is version 2. Why do we need this? It's because version 2 actually support the subnetting routing. Subnet routing, as you can see, we have used these subnets which belongs to /27. This is classless, so it's support the classless routing, and then it also support the subnetting which we have actually utilized on this lab. So we'll use that version 2. Okay, and then in the end we will have to type the command no auto summary, which actually ensure that the correct network is actually advertised. So now we need to type in the command network and specify the ID that is utilized on that network, in this case, or in that interface. In that case, let's start by advertising this network, which is 192.168.10.0, and then let's also advertise network ID, which is 10.10.10.10.0, which is this one. And then let's advertise this network over here, which is 80.80.80.0. Let's advertise another one. This is the last one, which is 70.70.70.0. and then let's type the command no auto summary. Okay, do right, exit. We're just gonna repeat the same configuration for all of these routers. All right, I'm just gonna do this in all of these routers. Let me move to this one and do the same thing. Enable config terminal, router rip, and then we need to actually specify version, which is version 2, and let's just type network 10.10.10.0, and then let's type in the 20.20.20.0 and do right. Let's further move on to this router over here, which is router 8. Enable config terminal. So we just need to type the command router rip version 2, and let's specify this network 20.20.20.0. Let's advertise another one, which is 30.30.30.0. no auto summary, do right. Let's see if we have actually done the same thing in here. Okay, we need to specify no auto summary, do right. Let's do the same thing over here. Enable config terminal, router rip version 2, network, which is 192.168.10.160, network, which is actually 30.30.30.0, network, which is 90.90.90.0, network, this interface, which is 40.40.40.0, no auto summary, do right. Let's move on to this router here, which is router 3. Enable config terminal, router rip. This is version 3, sorry, version 2. Where network 192.168.10.128. Network 40.40.40.0. Network 50.50.50.0, and then we are done. No auto summary. Do right. Let's move on to this router over here. Enable config terminal. Router rip. This is version 2. Network advertisement. Okay, we advertising 192.168.10.96. Network ID of 50.50.50.0. Network of 192.168.10.64. network of 60.60.60.0. no auto summary. Do right. Let's move to the last one. Router rip version 2. Network 192.168.10.32. network let's see, it's 60.60.60.0. network of 70.70.70.0. no auto summary. No auto summary. Do right. Okay, we have actually successfully configured the RIP, the routing information protocol. So now we just need to verify and then run some tests and see where the packet actually will go as we try to send the packet across. So first thing first, let's run the command to show IP route. As you can see, we have actually learned some parts based on the routing information protocol that we have configured in here. Okay, so I can actually show the database as well, but now let's go to this route over here. Let's see on this route over here, do show IP routes. Same thing applies. We have a number of networks that are learned via certain interfaces. All right, so let's now see what's going to happen exactly if we try to send the packet across. So for instance, before we do that, let's count these hops ourselves, and then so that we'll be able to see the possible outcome when we're trying to send the packet across from another network to another network. Let's start from, let's say we are actually trying to send the packet from VLAN 10. When I'm standing on a VLAN 10 and I'm actually trying to send the packet to VLAN 60 on the other end, my hops that I'll be looking at, I am expecting to see the packet move from reach to this router here, which is router 6, and then go to router 7 in the center and goes to router 2. Why is that? Because there are 2 hops in between. So we have these hops in here. This is the first hop and the second hop is over there. There is only 2 hops. So there is 1 and 2, and then let me just do this. So there's 2 here, and then from there is 1, 2, 3, and then in this side there is 3. There are 3 hops, and from here there is 1, 2, 3, 4, all the way to that VLAN 60. Only if I'm trying to get to VLAN 60. Those are the hops that will be actually looked at by the RIP, which is a routing information protocol. Remember, the RIP will use the hop count matrix and check which is the lowest path, which is the path that have the lowest number of hops. In this case, it's gonna use this one on the center when it's trying to get to this network over here, this broadcasting domain over here of VLAN 60. However, if I'm trying to send the packet from VLAN 20, same thing that will apply. If I'm calculating the hops from this router here, the first hop will go to here on this router 6, which is 1, 2, 3, 4. Now the number of hops will change. It won't be the same as if I was trying to send the packet that touched this router here. So basically I will have 4 hops if I'm actually from this one, and I can have one hop over here, 2 hop, and 3. This is the dead hop here. And then let's check if I come from this side, I can have 1, 2, 3. So it's either the RIP will use between these 2 links and see which one it can be used, these 2 parts actually, but it won't definitely use that one because it have the highest number of hops if I'm trying to send the packet from VLAN 20. Let's see that right now. Let's demonstrate using VLAN 10. I'm just going to try to move the packet from here, but before I do that, I have to ensure that this device over here have the IP address. Yeah, I'm just going to use that PC. I'm trying to simulate this so that we'll be able to actually see what's going to happen when we send the packet across from that part. Let me delete this. Okay, so what we're gonna see now, let's see, as I'm pressing that play, as you can see, we have that packet moving to that switch. Okay, we are expecting it to pass through R7. Okay, let's see. This is the first ping that we actually ran when we were trying to ping that PC1. All right, now let's wait for it. Okay, so what happened here, the RIP used this path which is utilizing 3. It didn't actually use this one. The reason why it didn't utilize this one is because when we're running the configuration of the RIP, we didn't actually touch this router over here, so it only sees 2 paths. It only sees the one that have 4 number of hops, and then it sees the one that have 3 number of hops. That is why it utilized that path, which is the upper part of our lab in here. So if I can try to configure the RIP on this router, which is router 7, you will see now it won't take the same path that it took right now. It will take this path over here via 80.80.80.1. Let's do that right now and see what's gonna happen. Okay, enable config terminal, RIP, router RIP, version 2, network that we're willing to advertise, it's only 2 for now. It's 90 and 80, 90.90.90.0 and 80. So it didn't take this path because on the routing table this path was not available. So this time around, it will actually take this path because it only have 2 hops. There is 2 number of hops. Okay,